Today I'm going to talk to you about multiplying rational decimals and fractions. Basically, all that means is that you're multiplying decimals and fractions that have negative signs. Here's a quick reminder of our sign rules for multiplying rational numbers, including integers. And the reminder says that any time you multiply numbers that have the same sign in the factors, your product is a positive. So positive times positive equals positive. Negative times negative equals positive. Anytime you multiply numbers where the signs are different in the factors, then the product has a negative sign. Positive times negative equals negative, and negative times positive equals negative. Also, remember on the tic-tac-toe board that any way you can make tic-tac-toe, if it's this way, if it's this way, if it's this way, or this way, any way you can make tic-tac-toe, all the possibilities show you the answers to the product of multiplying rational numbers. Oh, excuse me. So I'm going to go pretty quickly through the steps to multiplying decimals. This should be review for you, but I'm going to go through it as quickly as possible anyways. So when you see numbers that are written so that there are decimals in them, you have to rewrite them just like they're a regular multiplication problem. If the decimals line up, it's fine, but it's not something that you have to do. The second step is to multiply the numbers like there is no decimal there. And you can look at the picture over here and see that they just multiplied 6 times 3, wrote down 8, carried a 1, multiplied 6 times 4, got 24, added the 1, got 25. Then they multiplied zeros times 3 and 4, and then they added everything together. The next step is to count the number of digits after the decimal in each factor. In both of those factors, 43 hundredths and 6 hundredths, there are 2 digits after the decimal. So that means that we are going to put our decimal 4 places back in our answer. And then you just start at the end of your answer and move your decimal to the left in your product the same number of times you just counted. Here they've done it for you on the picture. They started at the end of 8 and they moved 1, 2, 3, 4 places and they put that decimal there. In this particular example, there's one more thing you have to do, which is if there are any empty spaces between the decimal and the product, fill in the blank with a 0. Then you're going to check your work. So basically what they did by checking their work was they took the answer and divided it by both of the factors in the problem. And their answer to that division problem was the other factor in the problem. So we're going to do a couple together. We have 1 and 45 hundredths times negative 9 and 2 tenths. So the first thing we're going to do is rewrite this like it's a regular math problem or multiplication problem times negative 9 and 2 tenths. You just rewrite it as though there's no decimal in the problem. And then we're going to multiply. 2 times 5 is 10, carry a 1. 2 times 4 is 8 plus 9 plus 1 is 9. And 2 times 1 is 2. Then I'm going to place my 0 here because I've already used this space. I'm going to come over and multiply 9 times 5 is 45. I'm going to carry my 4. 9 times 4 is 36, plus 4 is 40. So I'm going to write down my 0 and carry my 4. 9 times 1 is 9, plus 4 is 13. So now I'm going to add these together, bring them down into my product, and I'm going to count the number of decimals after, the number of digits after each decimal. In this one, there are 2. In this factor, there is 1. So that means that I'm going to need to account for 3 decimal places in my product. So I start here and I move my decimal 1, 2, 3 places. So my solution to 1 and 4500 times negative 9 and 2/10 is negative 13 and 340 thousandths. If I wanted to, I could drop that 0 and say negative 13 and 34 hundredths. I'm going to go ahead and do this next problem on the other side of the page. You can pause the video and you can try it on your own if you'd like. And then you can come back and check your answer. So I'm just going to rewrite these as if they are just 2 plain old multiplication factors. Like so. Now I'm going to multiply. 6 times 7 is 42. Bring down my 2, carry my 4. 6 times 5 is 30, plus 4 is 34. I'm going to carry this 3 here. 6 times 0 is 0, plus 3 is 3. And 6 times 0 is 0. Now I'm going to come down here and I'm going to put a 0 since I've already used this decimal number right here. Now multiply. 3 times 7 is 21. I'm going to carry my 2 in place of where I did carry a 4. 3 times 5 is 15, plus 2 is 17. Write down my 7. Carry a 1. 3 times 0 is 0, plus 1 is 1, and 3 times 0 is 0. Now I'm going to add these together. And then I'm going to count the number of digits after the decimal. In this factor, I have 3 digits after the decimal. In this factor, I have 1 digit after the decimal. So that means that I need to have 4 digits after the decimal in my product. So I come down here to the bottom and I start at the end and I count backwards. 1, 2, 3, 4, and place my decimal. So the answer to negative 3 6/10 times 57 thousandths is negative 2,032 10,000ths. So if you want to pause the video to finish writing this down, you may feel free to do so, but I am going to continue. Multiplying fractions even with negative signs, is a good bit easier than adding or subtracting fractions. All you have to do is multiply the numerators, then you multiply the denominators, then you simplify if necessary, and then you be sure to look at the signs to determine the sign of your product. So look at the example here. We've got 2/5 times 3/4. We multiply numerators and we get 6. 2 times 3 is 6. We multiply denominators and we get 20. 5 times 4 is 20. So our initial product is 6/20. But 6/20 can be reduced because they both can be divided by 2. 6 and 20 can both be divided by 2. So our final answer is 3/10. Now what happens if there's a whole number in my multiplication problem? Then all you have to do is put a 1 under the whole number in a denominator and multiply as usual. Be sure that you check your signs to determine the sign of your product. So in this example, we have 2/7 times 3. Well, then we took 1 and placed it under the 3 as the denominator, and then we just multiply the numerators. 2 times 3 is 6, and multiply the denominators. 7 times 1 is 7. This cannot be simplified because it is in simplest form. So let's do some together. Remember that we just multiply numerators and denominators. I can make my pen just a tiny bit bigger. So in this first problem, we are going to multiply 1 times 11, and that gives us 11. And then we are going to multiply 9 times 6, and that gives us 54. And we have a negative times a positive, and that tells us that our final product is negative. 11 and 54 do not have any common factors, so this is as simple as it can get. Let's look at this next problem. We have 5 times 5, and that's going to give us 25. And then we have 3 times 4, and that's going to give us, sorry, my pen's not cooperating, 12. And remember that we have a negative times a negative, which is a positive. This can be reduced. We don't want to leave it as an improper fraction. So how many times can 12 go into 25? That would be 2. And we have 1/12 left over, and it's positive. So this is our simplified answer. The last one has a whole number. So we've got 3 times -9 and 5/10. So we're going to put that 3 over a 1 and then multiply numerator times numerator. 3 times 9 is 27. And denominator times denominator. 1 times 5 is 5. And we have a positive times a negative, which makes it negative. So that I can reduce this, I just say 5 into 27 is 5, and I have 2/5 left over. Easy peasy, lemon squeezy.